Ladies and gentlemen, welcome to the 美式美景 Ophthalmology Center in Shanghai Hongqiao International Medical Center. I am the chief of this center, Dr. Mei Ying. My major is optometry. Shanghai Hongqiao International Medical Center is located in Shanghai Hongqiao Business District, which radiates across the Yangtze River Delta and covers up to 300 million population. It's close to National Exhibition and Conventional Center and the Hongqiao Business District, where is a world-class transportation hub. It explores and promotes the development of world-class health service industry clusters. Now, there are 8 hospitals and 1 shared medical technology center in Shanghai Hongqiao International Medical Center. Our goal is to build a comprehensive and sustainable international medical center, which is top in China, first in Asia, and in global. This international medical center we are building will be a high-tech, humanized, and multifunctional compound. 美式美景 Ophthalmology Center is constructed in compliance with the management philosophy of international standards, which means GCI, which is also the only partner of Kentucky School of Optometry in Medicine, Education, and Research in China. Meanwhile, we have cooperated with the Optometry Research Organization in the United States, the UK, Australia, and other countries in medicine, education, and research. Through all this, we established an industry-leading platform for ophthalmology practice and leading. By relying on the scientific research strengths of Shanghai Hongqiao International Medical Center and the teaching and training support of famous ophthalmology medical college and university, we are building famous doctor workshop, ophthalmology and optometry clinics, myopia prevention and control centers for primary and middle school students, children's eye disease centers, and the service system, including ortho-K, RGP, and vision training. 美式美景 Ophthalmology Center devoted to the promotion and development of the prevention and control of myopia in children and adolescents in long term. The vision care management system is implemented by 美式美景 Ophthalmology Center in Shanghai Hongqiao International Medical Center, which refers to the international GCI standard for full process quality control. We apply quality control management in the points before, during, and after contact patients. Our quality control implements maximizing patients' interest as the operation standards. 美式美景 takes advantages of mobile medicine, optical clinics, information management platform, medical data collection, and wireless transmission technology. To create a full process smart medical service, we could ensure the quality of the clinic process and operation management. At the same time, through a professional eye care management system, we are able to customize education tour, research tour, and other service for special membership, and the team experimental course, exploring the mysteries of the eyes, achieve education during entertaining. Thus, we create an innovative ophthalmology clinic experience of medicine, prevention, health, study, and tour. Our center also has a mysterious eye science museum with the theme of visual science, which is designed to allow children to learn about the visual health in the interactive high-tech games. With above all, we keep striving to provide better clinic experience while providing high-quality vision care service. Hello everyone. I'm very glad to be able to attend today's meeting. The topic I shared with you today is multifocal RGP, Fitting and practice. The mainstream theory of myopia control by using orthokeratology lens believes that the cornea will be specially shaped, which would include myopia defocus in the peripheral retina. If the anterior surface of the contact lens is made into a similar shape as the retina, it can also achieve the same effects as the orthokeratology lens, which is a multifocal contact lens, including multifocal soft contact lens and the multifocal rigid gas permeable contact lens, that's RGP. The above image on the left is a fluorescent pattern of the multifocal RGP, and on the right is a fluorescent pattern of the orthokeratology lens. Note that the multifocal RGP for myopia control is generally larger in diameter than the conventional RGP, usually between 10.0 to 11 mm. Large diameter design can reduce lens movement, stabilize the lens, and create a relatively stable myopia defocus in the peripheral retina. The multifocal RGP fitting is similar to the conventional RGP with a large lens diameter, but still provides good tear exchange. The procedure of multifocal RGP lens fitting, including the determination of the base curve, fitting evaluation, determination of the diameter of the lens, determining lens diopter, giving the order, lens order, incoming lens quality inspection, and the final distribution to the patient. These processes are similar to regular RGP fitting. I will briefly introduce them step by step next. Since the multifocal RGP diameter is larger, the base curve selection is usually flatter than the conventional smaller diameter RGP. Our experience is that if the corneal astigmatism is about 2 diopter, the corneal flat K can be selected as the base curve. If the corneal astigmatism is less than 1.5 diopter, the base curve should be 0.1 mm flatter than the corneal flat K. If the corneal astigmatism is greater than 2.5 diopter, the base curve should be 0.1 mm steeper than the corneal flat K. In the case above, the corneal astigmatism was 1 diopter, so we choose 0.1 mm flatter than the flat K as the base curve, namely the 8 point at 0.1 equals 8.1 mm base curve. This is a fitting video of the base curve of 8.1 mm. The lens has a relatively big movement in the vertical direction. The lower edge is lifting and the surrounding fluorescent deposit. Thus, this is a loose but acceptable fitting. This is a corneal topography map of a multifocal RGP wear, showing a tangential map similar to the blue eye topography after orthokeratology. Therefore, the effect of peripheral myopia defocus after wearing lens will be similar to that after orthokeratology and play a similar role in controlling the progress of myopia. If the base curve is tightened to 7.9 mm, we will see central fluorescent clearance and reduced edge lifting, which are not acceptable for overnight wear. This is the trial length of base curve of 8 mm. You can see that there's still fluorescent clearance in the center, which is a tight fit, but still acceptable. So for this case, we can set 8.05 mm as base curve. This is an obviously loose-fitting pattern. This lens has a base curve of 8.2 mm. The center of the cornea comes in contact in a large area with the lens, and the surrounding wrapping is obvious. This fitting is obviously too loose and not acceptable. There are large differences between multifocal RGP designs of different brands, which result in different topographic maps for each brand of multifocal RGPs. It shows that the optical area of the lens image is relatively small, and the defocus amount is also relatively small. The optical area of the right image is relatively large. Therefore, the defocus amount is also relatively large. Multifocal RGP can also be used to correct corneal astigmatism within 3 diopter. The topographic maps of this patient's eye both shows about 3 point diopter of corneal astigmatism. This is the topography of the case after fitting multifocal RGP. While the lens stabilized, we can see the appearance of the bruised eye ring. Some multifocal RGPs also offer designs for more complex surfaces. The toric multifocal RGP can fit the large astigmatism cornea better. Presently, according to the corneal topographic map and the optometry results, we can write a prescription according to the calculation and adjust according to the fitting calculation. This is a high astigmatism patient with a complex curved RGP topography. You can also see the performance of a blue eye ring. Therefore, for high astigmatism cornea, as long as the match is reasonable, the RGP with the complex surface can also achieve a very good myopia control effect. The diameter of the multifocal RGP is also an important parameter. As mentioned earlier, the diameter is usually larger than conventional RGP to reduce lens movement. Therefore, the defocal range achieves relatively stable peripheral myopic defocus, but the lens diameter should still be smaller than the cornea diameter, similar to the principle of the ortho-K lens fitting. Generally, the diameter of multifocal RGP is mostly between 10.4 to 10.8 mm, and the lens diameter accounts for 90% of HVID. Of course, the diameter of the lens can't be too large. The left picture is a fitting with an oversized diameter. We see bubbles under the lens. The lens has less movement, and the edge of the lens is beyond the limbus. The child has symptoms of discomfort and congestion after fitting. His parents are nervous and took a video and sent it to me. Generally speaking, the trick is to reduce the diameter of the lens. The relationship between the multifocal RGP diameter and the cornea is the same as the orthokeratology lens, and the lens diameter is about 1 mm smaller than the HVID. We should pay more attention to the determination of lens diopter while fitting the multifocal RGP. In general, multifocal RGP patients mostly have high myopia. During high myopia optometry, the distance of lens can significantly affect the final prescription results. Normally, during optometry, we would undergo a subject optometry after patients wearing trial lens to help deciding the precise diopter. However, it should be noted that if the lens is not suitable or has too big mobility, the multifocal ring area of the lens will move into the center of the pupil during optometry, so the defocal area located in the pupil region would affect the results of objective optometry. The diopter might be inaccurate, or it will form a high astigmatism. This causes a lot of trouble for optometry. Lens focus. Let's focus on the figure above. This is an aberration of the lens. It's quite deviated on the topography of the cornea while fitting. So during the objective optometry, the multifocal rings might move into the pupil area. The printed report will show a high astigmatism or a large deviation. The optometry will be difficult on this bias. In addition, because of the large lens diameter, there might be some bubbles under the lens while fitting, especially for those who are not skilled in fitting. This situation affects the final result of optometry. Nowadays, the multifocal RGP lens can provide adjustment of many parameters like BC, diopter, diameter, and also edge lift, optical diameter. Unlike the conventional software of corneal contact lens, the multifocal RGP could adapt to a wide range of diopter, and the highest diopter could be up to 20 diopter. Generally, when we do the incoming lens quality inspection in the clinic, we just verify the parameters of the lens and check whether the parameters are consistent, and inspect if the surface of the lens is normal and smooth, and whether there are defects and abrasion, and so on. But sometimes the manufacturers might produce a small amount of the errors on the lens. In this example, this patient complains of severe glare symptoms with correction vision of 20/20 in both eyes and a satisfactory fluorescent pattern without any significant signs. If we sent the lens back to the manufacturer for testing, and indeed found that the lens quality was defective, after recustomization, patient vision could be greatly improved. Therefore, after eliminating the fitting problems, it's necessary to use the manufacturer's professional equipment for testing. This patient has worn a pair of multifocal RGP lenses for 9 months with a visual acuity of 20/30 with lens on, and can achieve 20/20 with lens of -1 diopters. We changed the trial lens that has been used in first-time fitting. It is completely consistent with the result of optometry over refraction before 9 months. Thus, we consider that the lens was used improperly or the lens was deformed. We recustomized the lens with the same parameters, and the correct vision reached 20/20. This case suggests that it is important to retain the initial fitting data, especially the recording of the lens and optometry which has been used during the initial trial fitting. We can also measure the diopter of the RGP lens by using photometer, which is commonly used in optometry clinics, but you should be careful to use a specialized lens holder for measuring contact lens. We could also measure the base curve of RGP lens by using the module of dry eye analyzer. Therefore, we could measure the diameter of the customized RGP lens for verification by using the photometer and the dry eye analyzer, or corneal topography in the clinic. If the parameter are changed, we will need to make adjustment in time. To sum up, the design principle of the multifocal RGP lenses is similar to the orthokeratology lenses and the multifocal soft lens, which can be considered as a daily wear ortho lenses. Multifocal RGP has broadened the indication of myopia control and prevention in children. Many patients could choose multifocal RGP for myopia control, especially for those who cannot be fitted with orthokeratology lens. The corneal curvature might be too steep or too flat or some other special cases. However, the disadvantage of multifocal RGP lenses are poor comfort. Some patients have glass symptoms after wearing, which occurs in adults more obviously, especially those with large pupils. At present, the application of multifocal RGP lenses has just started in China with insufficient clinical data, and the myopia control effect still need further follow-up data support and more clinical research and exploration. Thank you for your attention.